Okay, these are the solutions for Wednesday night's homework. So this was number one. So for this one, there's really two ways to do this. You're really looking for the antiderivative of this. Okay, so since it's 1 over something, it's definitely going to be ln of something. But if you do a check on this part, the derivative of ln of that would give you 1 over this times the derivative of 5 minus 3x, which is negative 3, which means then you have a negative 3 too much, so then you're going to have to divide by a negative 3. So it would be, whoops, this. Okay? Or another way to think of it is, you can use u substitution and you can say u equals 5 minus 3x. Solve for du and then divide by negative 3. And then when you substitute, you could take out this dx and replace it with negative 1/3 du. Let me just make some room here. Okay, and then you're left with this, which is 1 over 5 minus 3x. But 5 minus 3x is equal to u. So you'd have that. And now, hopefully, this might be a little bit easier. The antiderivative of 1 over u is just ln of u. Okay, so this is going to be from 2 to 4. But before we replace the 2 and 4 in there, we'd have to go back and replace that u for what u is really equal to. And u is really equal to 5 minus 3x. Okay, so this is what we need to solve. Okay, so first I'm going to put in the 4. So 3 times 4 is 12. So when I minus a negative 1/3, that becomes positive. And then I have 3 times 2, which is 6. Okay, so I'm going to simplify. Now, really, just to, because this will be a problem here, it's really not supposed to be parentheses. This is really supposed to be absolute value. Okay, so we're going to get ln of absolute value of negative 7 plus, let's get rid of this, 1/3 ln of absolute value of negative 1. Okay, absolute value of negative 7 is positive 7. Absolute value of negative 1 is 1. Okay, we're going to simplify some more because this is none of the choices. And hopefully you remember that ln of 1 is equal to 0. So 0 times 1/3 is just 0. So your final answer would be this, and that was choice B. Okay, so this is number 2. So you're being asked to find the area under the curve from 0 to 7. And so when you look at this picture, hopefully, you're going to see some shapes in here. So right here we have a trapezoid. So the area of that is going to be 1/2 base 1 plus base 2 times the height. Okay, so base 1 would be the bases are here and here. So the first base is 1, the second base is 2, and my height will be this piece, which is 2. So 1/2 times 2, those cancel out, and you end up with 3. So this piece right here, the area of that is 3. Okay, then go to the next piece. Okay, so the next piece is going to be this trapezoid over here. Okay, we use the same formula. Okay, so let me get another color. So base 1 is this one, which is 2. I'm sorry, no it's not. Ignore what I just said. I'll go for another color. How about purple? Okay, so sorry, my bases are the parallel sides. So this is one base, which is 2, and then I have this base here, which is 3, and then this piece here is my height, which is 2. So again, these cancel, and I'm left with 5. So the area of this piece is 5. Okay, we have one more to go. Maybe we'll do a green. Okay. So now we have this triangle right here. Okay, and the formula is 1/2 base times height. And for this one, this is my base right there. That's equal to 2. And my height is right here. That's also equal to 2. So you have half of 4, which equals 2. But you have to remember that this 2 is located below the x-axis, so it's really a negative. So we have a 3, a 5, and a negative 2. That gives me 8 minus 2, which is 6, and that was choice A. Okay, sorry, I just took a break for a while. I had to go take Jojo for a walk to the supermarket because I'm making chicken cutlets for dinner tonight. Anyhow, so we have these two functions, and we need to find a whole bunch of craziness. So let's just do one thing at a time. So the first thing I focused on was this piece right here. So 0 to 10, 1/2 of some function of d of x equals 8. So we have a rule that says that you can take the constant and bring it out to the front. So if we do that, now you might say, how did I know to do that? Okay, because quite frankly, I just didn't know what else to do, so I'm just doing stuff and seeing where it leads me. Okay, if I multiply both sides of this equation by 2, this will cancel out, and I'll be left with this. But then if I multiply this side by 2, I get 16. Okay, so what did this just give me? This just gave me the integral from 0 to 10 of g of x equals 16. Okay, so we'll see what we could do with that. And we also know that the integral from 0 to 10 of f of x equals 21. Okay, so let's make some room here. Hi, Paula. I know you pretend you don't watch my videos, but I'm sure you're watching because this is so fascinating. Okay, so also what we were given is that this is that. Okay, so we had a rule that said that if you're adding or subtracting, you're allowed to break this up into two integrals. So I can do this. Oh, this shouldn't be plus, it should be minus, sorry. Okay, so I got that from this over here. Okay, so I just broke that up into two integrals, and I know that that is going to equal 2. Okay, and we're supposed to be finding this piece right here. Okay, so that's pretty much what we have. So I need to erase. I wish that this was a little bit bigger. I'm just going to leave that bottom one there. Okay, so we need to think about this for 1 second. This thing from 0 to 10, let's just look at g of x for a minute. Maybe I should go to a different color. Okay, this thing g of x from 0 to 10 is equal to 16. And we have this thing from 0 to 10 of f of x equals 21. Okay, so now at this point, it's all kind of getting mumble-jumbled, right? So let's think about this for 1 second. Even though we don't have a function, let's think of this. This is f of x. And we have some integral going from 0 to 10. I'm looking at this one right here. And so let's say this is 10. So we have some area under the curve. I have no idea what it looks like. But I know that this area from 0 to 10 is equal to 21 because they told me that. Okay, then I also know that I have another function called g of x. So when you don't know what to do, sometimes drawing the picture is a really great idea. And from 0 to 10, I'm using this now. We have some other picture, and the area of that is 16. But this is going from 0 to 10. We know from this piece right here, let's pretend this is 3 and this is 3 over here. The area from 3 to 10 of f of x minus g of x has to equal 2. Okay, so if you were to, let me take out this 21, I'm sorry, I'm kind of all over the place. There we go. So, here we go. So that would be a 3, and that would be a 3. Okay, so that's what we're looking for, this piece right here, okay? So if you took this piece from 3 to 10, f of x, and you subtracted this piece from g of x, then you would get 2, okay? That's what we're looking at. So, oh, I need some more room here. Let's go back from 0 to 10. Let's forget the 3 to 10 for a minute. What if we could do f of x minus g of x, but from 0 to 10? Couldn't I do that? Yes, I could. So let me take out my picture. I'm going to get rid of all this, clean it up a little bit, okay? I'm also going to get another color. Okay, so what if I do from 0 to 10, doing this exact same thing, f of x dx minus from 0 to 10 of g of x dx. Okay, f of x from 0 to 10 is right here. That's 21. Minus. And then I have this, 0 to 10 of g of x, and that was right here, and we got 16. And then we can subtract those, and we get 5. Okay, so from 0 to 10, it's going to be 5 when you subtract them. Okay, but we know that from 3 to 10 of that whole thing, we get 2. So kind of think of it, here's your number line, and let's say this is 0 and this is 5. Okay, and I'm talking about this 5 over here. So this whole thing, like this area here, is equal to 5. But I know that if I go part of the way, just like from here to here, then that part is going to be equal to 2. So what am I left with in this part? It would have to be 3. So the area from 0 to 3 is going to have to be 3. And that's why the answer is A. Okay, here's number 4. So this is more like the free response questions that we've been doing. So you have a cup of tea, cooling in a room. The room is always 70 degrees. So they're telling you that so that this way you can say, well, what if the room was colder at some point? Okay, so at T equals 0, before anything, the T was 200 degrees, so it's pretty hot. Okay, and then the T starts changing its temperature at this rate of R of T, and it's a negative number, so that would make sense that the T is cooling down, right? Okay. So what is the temperature of the T after 4 minutes? So we want to know everything that happened between 0 and 4 of R of T dt. Okay, so when you put that into your calculator, you're putting this in your calculator, there's no way you could do that by hand. So this would definitely be a calculator question. We get this amount. Okay, so this is degrees, and you can see there's a negative there. So that means the temperature went down by 24.8346 degrees. So what was it originally? 200. So then you're going to subtract that 24.8346, and you get 175.1654 degrees. But it asks you to find it to the nearest degree, so the nearest degree would be 175, which is A. Okay, and if you just look at this, this would make sense, that it started at 200 degrees, over time it's going to get cooler, now it's 175. If your answer was more than 200, then you would know that that's a problem. Okay, so that's 4, and we have one more to go. Okay, and finally this is number 5. And so we're supposed to find the area under the curve from 0 to 3, and we have this table. So it's saying, what could be the value? Well, We know if it's increasing. We've said before that if we have a function that's increasing, let's just say this is the area. If you take it from the left, you'll get an underestimate, and if you take it from the right, you'll get an overestimate. So what if we use a Riemann sum from the left and then from the right, and then wouldn't we know that the real number has to be in between? So let's start by doing it from the left first. So the first one is going to go from 0 to 0.5. The next one will go from 0.5 to 1, etc. Okay, so for each of these, the width is all 1/2. And I'm taking it from the left. So I'm going to have 0, 4, 10, 18, 28, and 40. Okay, so this is going to give me the following values. This one up here is going to be 14, and this one here is going to be 20. Okay, so I'm going to add all these numbers with these numbers, okay? And when I do that, so this is from, oops. Okay, so this is going to be from, something screwy with my camera. Okay, so when I take it from the left, when I add all 6 of those numbers, I get 50. Okay, now I'm going to do the whole thing all over again, but I'm going to do it from the right this time. Now, I know that the length is still 1/2 in between each one, so I could leave that there. Okay, so now I'm going to take the right values. So now I'm going to start with this right here, 4. Okay, and then when I calculate all these, I get this. This one is 20. This one is 27. Okay, so now I'm going to take all these numbers and all these numbers, and I'm going to add them, and so that's from the right. And when I add all those, I get 77. Okay, that means that the real value must be between 50 and 77. So if you look at all these, there's only one number. But now I just want to point out that, of course, they're putting 50 and 77 in there. So if you only do it one way, then they know that you're going to do that, and that's why those are choices. But the only number here that's between 50 and 77 is 62, and that's why the answer is B. And I think we are done. Oh wait, we had a quiz question, didn't we? Let me go over the quiz question real quick. So from the quiz today, this was the function, and we needed to know about asymptotes. Okay, so for vertical asymptote, you set the denominator equal to 0. Okay, so that means there are vertical asymptotes at 1 and -1, and so you had 5 choices. So I could immediately eliminate A, I could eliminate B, and I could eliminate E. Okay, now for the horizontal asymptote, the highest degree is in the denominator. So if the highest degree is in the denominator, then there is a horizontal asymptote at y equals 0. So if you look at a graph, y equals 0 is, my pen won't work. Okay, is at x equals 0. So there's also a horizontal asymptote at x equals, not x, y equals 0, it's the x-axis, sorry. Okay, so C says the x-axis, and that's why C was the winner for the quiz. Okay, now finally, that's it.